yes, we are doing 5-3 today. So, again, we do 5-3 first, and then we will do 5-2 tomorrow. Okay, so we go a little out of order there. So the first thing that we're going to learn about today is something called a median. Okay, a median of the triangle. And then we're also going to learn about an altitude. So the median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So I just want you to let that sink in for a minute. So it's a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So a couple things we have to look at. So the vertex of the triangle. So in this triangle, in every triangle, you have 3 vertices. In this triangle, the 3 vertices are what? A, B, and C. Okay, so this median is made with the B, that's one of the vertex. Okay, so that's one of the vertices. And then D, this would be the midpoint of the opposite side. And we know it's the midpoint of the opposite side because we have these 2 marks here that tell us each side is congruent. Okay, so we're actually going to draw another little picture. So we know that since each triangle has 3 vertices, how many medians do we think it has?
3. 1.
If there's 3 vertices, there are going to be 3 medians. Yeah, this should be just vertices, no I in there. I don't know why I put this in here. We don't need that. Okay, so since each triangle has 3 vertices, there are 3 medians for each triangle. So we're actually going to draw our own triangle, and we're going to put in all 3 medians. So I like to draw mine with a straight edge. You don't have to. Now when we draw our medians in, we're just going to estimate. Okay, but you could find the exact one, and you'd have to do what? You have to measure, right? Because if it's going to be the midpoint, you have to make sure it's going to be halfway. Okay, so if we call this ABC, okay, the first median we can do from B. Oh, that looks bad. I don't like that. I'm using a different color. Why don't I like that?
Because it's not straight.
Well, no, it doesn't have to be straight.
It's not even.
Yeah, I don't like that it doesn't look even. Okay, so I'm going to try it again. Okay, does that one look better? Yeah, does that look like these sides would be congruent here? Yeah. Okay, so we're going to call this D. Okay, so then BD is a median. Okay, let's try another one. So one vertice A, if I want, I really could measure this. So this is about 3 centimeters, so where would the median be? 1.5. Okay, so then maybe I would mark that first. That looks pretty good. And then again, you're just marking to show that it's a midpoint by showing that these two sides are congruent. And we'll call that E. Okay, so AE is a median. And then the last one has to go with what vertice? C. Okay, so let's look at AB. So for AB, again, that looks like it's about 3, so I'm going to put it at 1.5. Do you guys think I drew an isosceles or an equilateral triangle? Let's measure. Let's see. Oh, this one looks like it's 4, so it looks like I drew a what? Isosceles, because I have 2 congruent sides. And I'll call this F. So I have 3 dashes here, and then my last one is CF. So CF is a median. Okay, now you can see that I have these 3 lines intersecting here. Okay, so this point in the middle, I'm going to highlight that, is called the point of concurrency. Okay, so the point of concurrency of the medians of a triangle is called the centroid. Just kind of a cool word, right? So that's the centroid of the triangle. Okay, so this middle here, this middle portion, is the centroid. Okay, and when we say point of concurrency, that might be a new term for you. The point of concurrency is the center of gravity. Do you guys know what that means?
It's like we're all gymnastics.
That. So the center of gravity is where things are going to balance. Okay, so that's going to be the point where the triangle will balance. Okay, now note it says the centroid is always inside the triangle. So we're going to learn about a few other points today, and they're not always inside the triangle, but a centroid will always be inside the triangle. Okay, and we'll just draw a little picture of that. Okay, so no matter where my medians are, the centroid is always inside. Now, the centroid is also special, and it even gets its own theorem because of this special rule. And we call this the centroid theorem. So the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so in this diagram, P is going to be our centroid. And I'm going to give you the first equation. I'm going to see if you guys can come up with the other one. Okay, so the centroid of the triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so let's look at this line here. Okay, this segment AX. So 2/3 of the entire segment is going to be equal to the vertex to the centroid. Okay, so AP is going to be 2/3 of AX. Okay, so the centroid of the triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So the AP is what's going to be the 2/3 of the entire segment. Okay, let's look at this one here. Okay, so you have BY. So from B to P, that's going to be 2/3 of, do you guys think you can tell me? Of BY. So BY is the entire segment. Okay, what do we think the last one is? Okay, so we're going to start with CP, right? So vertex to the centroid. See how all of these are vertex to the centroid? So vertex to the centroid is going to be 2/3 of CZ. Okay, so let's just write some language there to help us. Okay, so each of these is the vertex to the centroid distance. Okay, and that was always 2/3 of, what is AX, BY, and CZ? What would we call those? They're medians. Okay, so they're the medians. Okay, so this is going to be 2/3 times the length of the median. Right, which is what the centroid theorem tells us. It's just kind of nice to put it in our own words. So from the vertex to the centroid, that distance is going to be equal to 2/3 the length of the median. Okay, so then we're going to use that in our next example. So it says in triangle LMN, RL equals 21 and SQ equals 4, we're going to find each length. Okay, so the first thing that we're going to find is LS. And I'm just going to highlight what we're trying to find. So we're trying to find LS, and we were given that SQ equals 4, so that's something that I might want to label on my diagram. The SQ is 4, and the RL is 21. Right, so the first thing I would do is I would try to set up an equation. Okay, so we know from the vertex to the centroid, that's going to equal 2/3 times the length of the median. So L to S, L is my vertex. How do I know L's a vertex and not R? Who can tell me that? Yeah, Brandon. Okay, so L is part of the triangle, right? Is R part of one of the vertices of the triangle? No. So the vertices of the triangle are N, M, and L. Those are what we would call our vertices. So L to S is going to be vertex to the centroid, and that's going to equal 2/3 of the entire median, which is LR, okay, or RL. So we just have to do 2/3. We know that LR or RL is 21. Do you guys know how to multiply without a calculator with fractions?
Yeah.
Okay, so what would you guys do to use mental math?
21 over 1.
Divided by 3.
Yeah, that's what I would do. So 3 goes into 21 how many times? 7. So then I really just have to do
7 times 2.
7 times 2.
14.
14. Okay, so LS is going to be 14. Okay. All right, and then we're going to do NQ. Do you guys think that you could do it? This one's kind of harder.
I know what the answer is, I just don't know how to get to the answer.
Sure. What's the answer?
It's 8.
Nope, but you're close. Well, because we're trying to find NQ. Yes, yes, good. Yeah, tell me how you thought about it.
Multiply by
Cause yeah, NS is 8.
Well, so
We divide it
it
by
told us that SQ was 4, so
Yep.
I knew I had to double it to get an S, and then add 4 to it.
Okay, so 4 is 1/3 of the line, right? So if you know what this is, you can always multiply that, right? So if this is 1/3, if you multiply that by 3, you'll get the whole thing. You'll get 12. Okay, so remember that NS plus SQ equals NQ. Okay, we know that NS is going to be 2/3 of whatever NQ is. And we know that this is 4. So if we wanted to solve this algebraically, we could do that because we wrote this in terms of NQ. So I could just subtract 2/3 NQ. And you kind of treat it just like an X, right? What's the number in front of NQ?
negative 2/3.
Sorry, the first one. 1, right? So it's really like you're taking 1 NQ and you're subtracting 2/3 of it, and how many's left? 1/3. So then if you were going to solve this, you would just multiply both sides by 3, and you'd have 12 equals NQ. Okay, and then you could also just think of it in terms of logic, which is what Caitlin was talking about. So if you know that SQ is equal to 1/3 of NQ, you could just take 4, multiply that by 3, and that would give you 12. Or like Caitlin said, if we were trying to find NS, we know that's 2/3, so we could just multiply that by 2. Okay, so either way you're going to get 12. Okay, so you can do that either way. Obviously, I know some of you are just going to use the logic. That's perfectly fine. I want you to see how else you can do it with algebra. Okay. All right, let's flip it over. Okay, so the other thing that we're going to learn about today is called an altitude. And you probably have heard altitude before. What does altitude also mean? Okay, so and with a triangle, it is going to be the height of the triangle. Okay, and whenever you have the height of a triangle, what always accompanies it?
The base.
I don't think I heard it yet.
A midpoint.
If it's the height, what? No. If it's the height, what will be marked in it?
Oh, a median.
Mm-mm. No. How do I know that like this is not the height?
Because it's not straight.
Okay, if it's straight,
It's not marked.
a right angle, right? Okay, so there'll be a right angle.
Oh.
So just like with the height, how there has to be a right angle, it's the same thing with the altitude. Now with the median, did we have to have a right angle? No. Okay, so the altitude is going to be special. Molly, you with me? Okay, so the altitude of a triangle is a perpendicular segment. So if it's perpendicular, that means it's going to form a right angle. And it's from a vertex to the line containing the opposite side. Now this is different from the last one. In the last one, it had to be to the midpoint. This one does not have to be to the midpoint. It's whatever is going to make that 90-degree angle. Okay, so every triangle has 3 altitudes, just like the medians. But the altitude can be inside, outside,
Next to it.
or on the triangle. Okay, so it can be inside, it can be outside, or it can be on the triangle. Okay, so we're going to go ahead and we're going to draw the altitudes in for this triangle. So the first one I'll draw is the one from Q, which will probably be one of the easier ones to draw. Okay, so again, this does not have to be the midpoint. It just has to form a 90-degree angle. And then so I'm going to put that 90-degree angle right on there. Okay, and we'll just call this Y. Okay, so QY is one of your altitudes. Okay, and then there's that little X there. That's because that's where my next one's going to go. So from R, remember you want a right angle. So we're going to draw this from R to X. And we can definitely see that that's not the midpoint, right? Yeah, because those are not equal. Okay, so that would be RX. Okay, and then the last one is from S. Okay, and again, we're trying to get that right angle. Okay, and we'll just call that Z. So those are my 3 altitudes. Okay, now remember, again, you have that point in the center. Last time, the point in the center was called the what?
The centroid.
Okay, so for medians, the point in the center is called the what?
Centroid.
Okay, we'll try it one more time. So for medians, the point in the center is called the centroid. Okay, now for altitudes, we have something different.
The altoid.
No, unfortunately not. Okay, so the point of concurrency of the 3 altitudes is called the orthocenter. Yep, it's called the orthocenter. What's it called? Orthocenter. Okay, and that is for the altitudes. Okay, so our next example we are going to find the orthocenter, and I'm going to draw some triangles with you. Okay, and yours don't have to look exactly like mine, but they need to have a certain type of angle. So if we were classifying this by its angles, we'd say this triangle is what?
It's scaling. Oh wait, no. Yeah, no.
It's not obtuse, it's not scalene. It's not right, because it's R, Q, or S, right?
Acute.
Acute, right? Because all of the angles are
They're less than 90 degrees.
less than 90. Okay, so this is an acute triangle.
That's a acute.
Okay, so we are going to draw an obtuse triangle. No hitting on my triangles, okay? Okay, we're going to do the obtuse one first, and you're going to have to give yourself some room here. Okay, so I'm going to start here. And again, you just have to make sure you have an obtuse angle. Okay, so that's my obtuse one. Okay, and like I said, we're going to give ourselves plenty of room here. And then the other one we're going to do is a right triangle. So we did acute, obtuse, and now we're going to do a right one. And for this one, you don't need as much room. Okay, but you do have to make sure it is a right triangle. Okay, so we have an obtuse and we have a right, and then we have to find the orthocenter. So in order to find the orthocenter, what we're going to do is we're going to find the altitude of each side. Which one's probably going to, well, let's go ahead and we'll label these. So this will be A, B, C. A, and for this one, we'll do A, B, C again. Okay, so what is probably going to be the simplest altitude to draw?
B.
The one with B. So let's go ahead and try to do that one first. The one with B. Okay, so what I'm trying to do here is I'm trying to go just straight across to the other side so that I get a right angle. Okay, and if the first time you don't get it right, that's okay. We'll erase it, we'll start again. Because remember, the last one, I didn't get that right the first time. I had to start mine again too, so that's fine. Okay, so yeah, now we have to do A, right? Is there any way that A is going to be inside this triangle? No, none of those would be right. So what we have to do is we're going to have to extend the sides. And to do that, what we do is we just make a dashed line. And once I'm able to do that, then I can make a right angle. Okay, so the median here, the altitude here is going to be outside of the triangle. And then the same thing for C, right? So it has to connect to what side? C has to connect to what side?
A.
Well, what side? So A is in a side,
AB.
right?
CA.
So AB. So I'm going to extend AB. So I'm going to have to extend it downward, right? Because if I extend it upward, am I going to be able to get a right angle? No. So it would have to be able to intersect it. So we can see that when you have an acute angle, that is going to be the simplest one to do. If it's obtuse, you're going to have to extend. Okay, and now I can draw the altitude here. But wait. There's more. Okay, so if you call in the next 20 minutes, just kidding, you want to form your, what are we trying to find?
The centroid. No, not centroid. The
The
orthocenter.
orthocenter. And to do that, all three of these lines have to do what?
They
Intersect.
So
So
you draw them longer.
do I have to draw them longer?
So much time.
Okay, so then let's draw these longer. So to extend them, again, remember when you extend, we're just going to make a dash line.
Why are we extending?
Well, so we want all of them to intersect with each other. Yep, they don't intersect yet.
I tried it out. I think I drew my triangle.
Okay, so then if I extend my middle one,
Like two of them did. And the other was just like going that line.
yep, so if they don't intersect, you want to keep going until they do.
I don't have enough room.
Infinity. Yeah.
You don't have enough room, I told you, you gotta leave yourself a lot of room.
My triangle's like lost.
My triangle is lost.
Oh, you mean like it's off the page?
Yeah, mine's kind of off.
Oh my god, you made the biggest triangle.
Oh.
It's just like gone.
Yeah, mine
Mine's just
kind
going
of looks
straight.
like
Like,
yours.
they just made
Dude,
like
look at
one
mine.
big triangle.
Ow.
Look at they make one big triangle.
Off brand.
Hey, that is enough.
When it's supreme but with two P's.
It angers me. This is
Or like it's spelled wrong. Like it's actually spelled.
Yep. So then your ortho center to here. Really, that one should be there.
Outside of the thing.
okay.
Yep, it's gonna be outside of it. So I'm gonna put my. Okay, so if it's acute, we saw that it was inside. Let's write that down. If it's acute, the ortho center is inside. If it's obtuse, the ortho center is where? Which we can remember, obtuse outside. So for the right triangle, where do we think it's going to be? All right, let's see. Let's see if we're right. Hey, now, again, the first one that you draw, the simplest one to draw, is going to be the one from B.
Yeah.
Okay, so let's go ahead and do that one first.
Then it goes right to the
Make
little
me a
thing.
sandwich.
Right here. All right, and then the one from A to the opposite side. So the opposite side is BC. So if you're drawing that, it's just going to be this line here.
That's so creative.
Okay, so it actually is the side of the triangle.
Hey.
Okay, now if I'm drawing it from C to AB, again, guess what?
On the line.
It's on the side of the triangle. Okay, so your ortho center is B.
Pretty neat. So wouldn't for a right
Okay.
triangle, wouldn't it be where like the 90-degree angle is?
Mhm.
Like every time?
That. Yep.
Wow, that just makes life
That's
easy.
easy.
Okay, so and that will be again that will be on the triangle.
It would be better if it would have been open.
Okay. All right, so then your homework is page 317. And again, remember it's 5-3. And we're doing 3 through 6, 12 through 15, 21 through 23.